So Rolle's theorem, you had to say it was differentiable. You had to say that it was continuous, and then what you were doing is in that, what Rolle's theorem said is if you could show that those two things were true, then you could find an absolute max and you could find an absolute min, right? Yes. So what we're doing when we do the mean value theorem, which is probably one of the most important theorems there is in calculus, in my one simple, humble opinion, is that you still have to be continuous on the closed interval. You still have to be differentiable on the open interval. In other words, you could not be able to find the derivative of the endpoints. That's okay. There exists a number c such that when you find the slope of those points, it's going to equal the derivative. You're going to be able to find a derivative that's equal to the same number. Everyone understands that this is a slope, yes? The difference of the y's over the difference of the x's, that's a slope. So if I find, so what I'm going to do is, given that the function, I'm going to find all the c in all the values of c in the open interval that satisfy the mean value theorem if it applies. So the first thing I have to do is I have to say, is this function continuous in the interval from 0 to 1? And you say yes. So I'm going to say continuous on 0 to 1, and you say yes. And then the second thing I'm going to say is differentiable. And it can be on the open interval 0 to 1. So am I going to be able to find a derivative? And the easiest way for me to do this is sometimes I just graph it to see what it looks like. And did anyone graph that? I'm going to go with none of you probably graphed it. So probably can we graph it? So here it is. So you have this graph here. So remember, I'm going on the interval from 0 to 1. So I'm going from here to here. And it's the open interval. The only place that this function does not have a derivative is when x is equal to 0. Does that make sense? So since it's not differentiable, I'm going to write this, not differentiable at x is equal to 0, but that's okay. Why is that okay? Because it's one of those, it's kind of like the absolute value function when you change the slope too suddenly. You have like, I call it a sharp point. You like here your slope is, let's say, like -1 and it's going rapidly negative, and then all of a sudden you start going rapidly positive. What would that look like? Like that would be differentiable. Even a curve like that, even a steeper curve like that, as long as you have a chance. Yeah, it's like, think about being on I'm sure I told you about the roller coaster. Did I not tell you about the roller coaster? Like if I'm on a roller coaster, like there is not a roller coaster that exists that does not have some type of point where you hesitate and stop for a second. Like you have to think about going on a roller coaster. You go up and then you kind of like don't move, or you stop and you're not really going up or down. That's technically when the derivative is equal to 0, and then you drop down. You could not ride a roller coaster like that. Well, of course you couldn't ride a roller coaster like that. You'd die. But if it went the opposite direction, and I don't know that I can draw it the opposite direction. I don't think I can. If it was something like that, think of it. It's too much of a peak. You couldn't get over that peak. Does that make sense?
Yeah, anything like sharp return.
Yeah, and that's the best way to think of it. If you have a super sharp point or super sharp turn, yes, then you can't do it. All right.
Find the derivative.
All right, moving on. So it's not differentiable at x is equal to 0, and that's okay because it does not contain the point 0 because it's an open interval. Are you good? Yes. Now what I want to do, to do Rolle's theorem, I want to find f of 0. I want to find f of 1. Those are my two endpoints. Are you with me? So I'm going to do x, well, I'm going to do 0 to the 2/3 power, which will be 0. And then I'm going to do 1 to the 2/3 power, which will be 1. So now I'm going to do f of, so now I'm finding the slope between those 2 points, yes? So I'm doing f of 0, which is the y value, minus f of 1 over 0. So I'm going to do, in this case, 0 minus 1 over 0 minus 1. It's going to be 1. So that means somewhere in the interval from here to here, there has to be a place on that line where the slope is equal to 1, where the slope of the tangent line is equal to 1. So in order to find the slope of the tangent line, I have to take the derivative of this. Yes, yes, Mrs. Ward. So, oh, that's in my way. So I have too much here. So when I take the derivative, I'm going to take 2/3 times x and then subtract 1 and get negative 1/3. And so I would probably rewrite that like 2 over 3x to the 1/3. Yeah? Now I want to set it equal to what number? 0. No. 1. You want to set it equal to the slope of the secant line, right? We agree that this is a secant line? The average rate of change, the one that you complained about on the test? Yeah. So now I'm going to do 1 is equal to 2 over 3x to the 1/3. How are you going to solve that? You can think of this as one of the one you can cross multiply, or you can multiply both sides by 3 times x to the 1/3. So when I do that, I'm going to have 3x to the 1/3 is equal to 2. This is in my way. I don't, how do I solve that? I cube it. I don't cube root it, I cube it. So I'm going to raise this to the 3rd power because the 3 times the 1/3 would be 1. And then raise this to the 3rd power, so I'm going to get x is equal to 8/9. Then I have to ask myself, is 8/9 in that interval from 0 to 1? Yes, so that would be my, and we're calling this C right now. It's not a critical number. It is a C value in that interval that has the tan slope of the tangent line equal to the slope of the secant line.
Wait, so is it differentiable?
It was differentiable at 1. It's not differentiable at 0, but that's okay because that 0 is the endpoint. I feel like we need to do another. So here I have this one. I have f of x is equal to x plus 1 over x. So the first thing I'm going to do is find the slope of the secant line on that interval. Yes, sir? So now I'm going to find f of 1/2 and f of 2. Oh, wait, stop, pause. Is not you. Is it continuous over that interval of 1/2 to 2? Yeah, the only place that this function is not continuous is when x is equal to 0, right? And then is it differentiable? Don't know. Probably have to graph it. Did anyone graph it? Okay, don't even have a sneak graph here, do I? No. I'm going to find the derivative in a second. I wonder if I should find the derivative first, and then I can answer those questions. I don't talk to myself. I don't know what you're talking about. Did anyone graph it for me? Can I take a peek at the graph? That's beautiful. So the graph is, so it's not continuous at 0, but that's okay because 0 is not in my interval. So I'm happy about that. All right, so moving on. So did anyone find f of 1/2? Three? 3/2. So now I want to find the slope of the secant line. Which is that f of 1/2 minus f of 2 over 1/2 minus 2. Doesn't matter what order you do it in as long as you're consistent. Yes, Mrs. Ward. Okay. So this is going to be 3 minus 3/2 over 1/2 minus 2. Is that right? So this is the slope of the secant line, yes? Good catch. Now what do? Find the derivative. So I'm going up here and finding the derivative. I have a question. Are we leaving it like that and doing the quotient rule, or we're going to divide by x? Okay, so I'm going to rewrite this. F of x is equal to x over x plus 1 over x, yes? So this would be 1 plus x to the negative 1. Everyone agree? So when I take the derivative, that ends up being 0 minus 1 x to the negative 2. So negative 1 over x squared. Now what do I set that equal to? Negative 1. Set equal to this secant line. So I get x is equal to plus or minus 1. So positive 1, negative 1. Which one am I going to use? Am I going to use both of them? No. Just the positive one. Why am I just saying c is equal to 1 and not the negative 1 as well? Yeah, because if I go back to this interval from 1/2 to 2, only 1 is in that interval. Make sense? This isn't terrible, is it? Huh?
Easier than the other one. Maybe not.
I'll give you a second to read. Sorry, Andrew. And then we could put another order pair as 5 and 390. So we can do the difference of the y's over the difference of the x's. So 1500 minus 390 over 0 minus 5. And when I do all that, if I'm having a good day, am I having a good day? I hope I'm having a good day. Really? You have a calculator.
I thought.
I get a negative 222, which matches this. If it were equal to any other number, I could not make that assumption. It has to be exactly equal. Does that make sense? So that's the, oh, and then I should say things like it's a continuous function. Why is it a continuous function? Is there ever a break in your temperature? Like you think about your coffee. Is there ever a break in your coffee cooling down? No. No, it's probably going to be something like, the temperature will probably be something like this, where this horizontal asymptote would be the room temperature, yes? Does that 90 degrees have any input on this problem whatsoever? No, none. That should be the where you end up though. Any questions on this? Okay, now this is where you get angry with me.